FastMCP 3 employs a transform-based architecture to dynamically modify tool discovery and execution workflows, enabling runtime customization of the Model Context Protocol (MCP) server's behavior. This specific artifact demonstrates how the CodeMode transform replaces direct tool exposure with a metatool layer, allowing the LLM to discover and execute tools through a controlled Python sandbox environment. The upcoming code snippet will reveal how the CodeMode transform is configured with an empty discovery toolset and a custom execution description, effectively bypassing the default discovery pipeline in favor of a single-stage workflow where tool specifications are embedded directly in the execution prompt. This pattern is particularly useful for servers with a small, well-defined toolset where minimizing round-trip discovery overhead is prioritized over dynamic exploration. From FastMCP, import FastMCP. From FastMCP experimental transforms CodeMode, import CodeMode. CodeMode equals CodeMode. Discovery tools equals. Execute description equals. Available tools, \n. Add int y, int, add two numbers \n. Multiply int y, int, multiply two numbers \n. Write Python using await call toolname, params, and return the result. MCP equals FastMCP server. Transforms equals CodeMode. This code demonstrates a single-stage discovery pattern in FastMCP 3's CodeMode, where tool execution descriptions are directly embedded in the execute description parameter rather than discovered dynamically. The CodeMode transform is configured with an empty discovery tools list, bypassing the default three-stage discovery process: search, right arrow get schema, right arrow execute. Instead, the LLM receives all tool information up front through the execute description, which explicitly lists available tools, add, and multiply with their signatures and usage instructions. This approach minimizes round trips by eliminating discovery steps, making it ideal for simple servers with a small, static toolset. The trade-off is increased token usage in the initial prompt, as all tool descriptions are included regardless of whether the LLM uses them. The execute description also provides explicit guidance on using await call toolname, params, and returning results, ensuring the LLM understands the execution model without additional discovery. This pattern is best suited for scenarios where the tool catalog is small, e.g., fewer than 5 tools and unlikely to change, prioritizing simplicity over dynamic discovery flexibility. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which serves as the base class for creating Model Context Protocol (MCP) servers. This import enables the creation of FastMCP server instances that can handle component flow and transformations in the MCP ecosystem. From FastMCP experimental transforms CodeMode, import CodeMode. Imports the CodeMode class from the FastMCP experimental transforms module, which provides functionality for code-related transformations in the component pipeline. CodeMode equals CodeMode. Creates a CodeMode instance and assigns it to the variable CodeMode. The line shows the start of a constructor call with no visible parameters yet, indicating a new CodeMode object is being instantiated. Discovery tools equals. Initializes an empty list named Discovery Tools that will store tool discovery components for the FastMCP server. This list will be populated with transform objects that modify how tools are discovered and presented to clients. Execute description equals. Assigns an empty tuple to the variable execute description. This creates a sequence that can later be populated with execution details or metadata, though the current assignment initializes it as empty. The variable name suggests it will store descriptive information about some execution process.
Available tools, \n.
Outputs a literal string, available tools, \n, that appears to be a header or label for listing available tools in the FastMCP system. The newline character at the end suggests this will be followed by the actual tool listings on subsequent lines.
Add x, int y, int, add two numbers \n.
Declares a method named add that takes two integer parameters, x and y, returns an integer, and includes a docstring describing its purpose of adding two numbers.
Multiply x, int y, int, multiply two numbers \n.
Declares a function named multiply that takes two integer parameters, x and y, and returns an integer result. The docstring indicates this function multiplies two numbers, though the actual implementation isn't shown in this segment.
Write Python using await call toolname, params, and return the result.
Asynchronously calls a tool named name with the provided params using the FastMCP client's callTool method, then returns the result of that tool execution. The await keyword indicates this is an asynchronous operation that will suspend execution until the tool call completes.
MCP equals FastMCP server. Transforms equals CodeMode.
Creates a FastMCP server instance labeled server with a single transform named CodeMode applied. The transform will modify components as they flow through this server, acting as a filter in the pipeline between providers and clients. The server identifier server appears in MCP protocol handshakes for client identification, but doesn't control operational behavior. FastMCP3's CodeMode transform streamlines tool execution by collapsing the three-stage discovery process into a single-stage workflow. By configuring discovery tools as an empty list, it bypasses dynamic discovery entirely, instead embedding tool specifications directly in the execute description. This approach front-loads all tool information, like the add and multiply functions, into the initial prompt, eliminating round-trip overhead at the cost of higher token usage. The execute description not only lists available tools, but also provides explicit execution guidance, ensuring the LLM understands the sandboxed environment and the await call toolname, params pattern. This pattern is optimized for small, static toolsets where minimizing latency outweighs the flexibility of dynamic discovery. The CodeMode transform is then applied to the FastMCP server instance, creating a controlled execution pipeline that prioritizes simplicity and predictability.
The empty server whispers tools into existence when summoned from the void.